let's find a couple antiderivatives that involve our hyperbolic functions. So first, we'll find the antiderivative of the hyperbolic cotangent of theta over root 3 with respect to theta. And then the hyperbolic cosecant of the natural log of t times the hyperbolic cotangent of natural log of t all over t dt. Well, first things first, let's get started on this one. And just right from the top, I'm going to go on and see if I can make this one just a little bit easier to deal with a little substitution. So I'm going to let t equal theta over root 3. And then dt would equal d theta over root 3. And then finally, d theta would be root 3 times dt. Making our substitution, we'll get the hyperbolic cotangent of t dt, and I've gone on and pulled that root 3 out front that comes along with that dt. Well, off the top of my head, I don't know a rule for the antiderivative of the hyperbolic cotangent function. Some of you watching the video might actually know this one off the top of your head, and that's great. But since I don't, I'm going to rewrite this in terms of cosh and sinh. So the hyperbolic cotangent function is cosh over sinh, and now I think I see what I can do. I'm going to do one more substitution. I'm going to let u equal the sinh of t. du is then cosh t dt, and so I see the entire expression for du here. So I have root 3, and this is going to be 1 over u du, and I'm ready to find an antiderivative. Root 3 times the natural log of the absolute value of u plus c, but u is equal to the sinh of t, and t, before I even write it down, is equal to theta over root 3. And there's my nice, happy antiderivative for the hyperbolic cotangent of theta over root 3. And I've chosen to do this by using 2 substitutions along the way. All right, in this example, this is probably the more intimidating looking of these 2 examples, but it is actually just 1 substitution away from being a very straightforward antiderivative question. See, when I look at this, I see an inside function of the natural log of t and its derivative 1 over t in the problem, right? Because I have a 1 over t right here. So 1 over dt, that's my du. And we can change this into the hyperbolic cosecant of u times the hyperbolic cotangent of u du. dt over t is my entire du, and I just happen to know this antiderivative formula. This is minus the hyperbolic cosecant function of u, of course, plus c, and use that nice happy natural log of t. So there are 2 antiderivative examples using our hyperbolic functions.